Hello everyone, welcome to this course on Oracle Cloud Infrastructure Foundations. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this particular module, we are going to look at the various database services offered by Oracle Cloud Infrastructure. Specifically, we are going to look at the different options and then talk about what we have DB systems, what we call them as managed database offerings called DB systems. We'll look at the two unique characteristics for backup and high availability and disaster recovery, two of the most important things for any of the database. And then finally, we'll look at autonomous databases. This is a foundation lecture, so I'm not going to dive deep into lots of details here, but hopefully this should give you a quick overview of the different options we have available with Oracle Cloud Infrastructure. So the first option we have is what we call as VMDB system or virtual machine DB systems. With this option, basically you get a virtual machine where you have a managed Oracle database instance running and you have different shapes. These use block storage and there's also something called fast provisioning available here. So you can provision your databases really quickly. And in that case, we use something called logical volume manager instead of ASM, the standard ASM option you get with Oracle databases. And again, you can read about all the details here, but this particular offering is about running your managed Oracle database in a virtual machine, along with leveraging the block storage which OCI provides. The second option is called bare metal DB systems. In this case, as the name suggests, you are running the Oracle database in a bare metal machine. And these are 52 core bare metal machines. You get 51.2 terabyte local storage. So here you are leveraging the local storage. And the idea here is that you get really fast performance. The third option is what we call as Oracle Rack. An Oracle Rack enables you to cluster Oracle databases. In case of Oracle Rack, servers share a disk and have the same Oracle database, but with different instances running on each node here. If one node fails, the connection fail over to the other nodes. The instances themselves don't fail over because they are just the processes on each server that access the same data. Oracle database is available from any of the nodes in the cluster. So we have rack available, and the shape we have here is a two-node VM rack. But this is a managed offering, and it's available out of the box for you to leverage. Idea here is you get managed high availability. Third option, or the fourth option, is Exadata DB systems, and basically this is a managed Exadata infrastructure, including servers, storage, networking, firmware, hypervisor, etc., all managed by us, and you can leverage Exadata as a service. And finally, we have autonomous, and the three key characteristics of autonomous, which we talk about, are self-driving, self-securing, and self-repairing. What it means: self-driving, we automatically patch, upgrade, tune without requiring any human intervention or downtime. We also support things like online scaling of CPU and storage. Self-securing basically means that we have encryption by default, and we also have features like Oracle Database Vaults and Oracle Data Safe, which helps you identify sensitive data and mask it. And then finally, what we mean by self-repairing is we automatically protect from all types of downtime, including things like system failures, maintenance, etc. So really, it's a continuum, like you saw with compute, storage, etc. Same concept here, and you have different options with some of the with different characteristics, and depending on what you are looking for, you could use one service over another. Now let's look at some of the DB system capabilities first, and then we'll talk about autonomous. So you can see the bunch of features we talked, the bunch of offerings we talked about: the VMDB systems, the bare metal DB systems, Oracle Rack lets you cluster your DBs, Oracle database, and then Exadata. Well, that's the first thing, right? You get different kind of options depending on your use case. You could use one over another. We have complete life cycle automation, whether it's provisioning, backup, patching, all that is supported. We support things like rack. We talked about that briefly. Also data guard, we'll talk about what that is. We also support dynamic CPU and storage scaling, and we'll look at which option supports what. Your bare metal supports CPU scaling. Your virtual machines support storage scaling. Why? Because it makes sense. These uses block storage. Blocks bare metal uses local storage, so you can change the CPU, but not the storage. Virtual machine, you could change the storage, not the CPU. And then there are lots of security options available, encryption, using OCI services like identity, etc., etc. And then finally, we also support bring your own licenses. So if you have on-prem licenses, we talked about that in the pricing module, you could actually use those licenses in the cloud. Well, we talked about that. You could start, stop, reboot DB systems. For bare metal DB systems, the billing continues in stop state because again, you're using a bare metal machine, has local storage here, so you're paying for that. Virtual machine DB systems, you don't. Scale, we talked about. You can scale the number of CPU cores for bare metal. For virtual machine, you can scale the amount of block storage with no impact. Patching we support, it's a two-step process. First, you patch the server where the DB system itself, and then you patch the database which is running on top of that. Now, the important things to keep in mind when you're talking about databases are things like backup restore, high availability disaster recovery, and performance. But this is a foundations course, so we are going to skip performance. But let's talk about backup and restore because that's a key design consideration. So we talked about some of these constructs earlier. You have a region, you have availability domain, you can have one or three. In this case, I'm just showing one. You have a virtual cloud network running here, and then you are running a DB systems within that network. This is running in a private subnet, so it's not accessible by entities outside on the internet, for example. Now, we also talked about in the networking module a gateway called service gateway, which lets you take backups from the database to object storage. And object storage, remember, is a public service, so has a public endpoint. But the fact you are using service gateway, what it does is it lets private endpoints like a DB systems, which doesn't have a public IP address, talk to object storage, which has a public IP address and a public endpoint, and the traffic is still secure. It stays on Oracle network backbone. It doesn't go to the internet. So that's basically what service gateway does. Now, using that, you could do manual backups. You could do automatic backups. Automatic backups, as you see here, are written to object storage. There is a particular window in which it runs. There you could keep the backups for 7 days, 15, 30, 45, or 60 days, of course. And you can always archive it for in object storage for long-term archival, but these are the preset retention periods we support. And you could recover the database. So if, let's say, the primary database has a problem, you could always recover from your backups, and there are different options for recovery. Well, let's look at disaster recovery because again, this is one of the key considerations. We looked at backup and restore. Let's look at disaster recovery. So similar example as before, we have a region. Now I'm showing 3 ADs, and we'll talk about a region with 1 AD as well. So let's say you're running a primary DB here. And of course, this is sensitive. It has all your data. You want to protect that data, right? So we have a capability in Oracle called Oracle Data Guard, which provides a set of services that create, maintain, manage, and monitor one or more standby databases to enable Oracle database to survive disasters and data corruptions. So the way it works is a data guard configuration consists of one primary database and one or more standby databases. Now, in case of Oracle OCI, we support only one standby, but in on-prem you could actually have one or more. Once you create a data guard configuration, as you see here, Oracle Data Guard automatically maintains each standby database by transmitting redo data from the primary database and then applying the redo to the standby database. So if the primary database becomes unavailable because of a planned outage or an unplanned outage, Oracle Data Guard can switch any standby database to the primary role, minimizing the downtime associated with the outage. So this becomes primary in case of an outage. and then you could work on your primary database, and you could do the vice versa. You could move it back to primary again. There's also this thing called Active Data Guard. Active Data Guard extends Data Guard by providing advanced features for data protection and availability. For specific Oracle versions like Extreme Performance Edition and Exadata, it is included by default. Otherwise, you have to pay for that. And as we talked about, there are two modes for data guard. One is called switchover, which is planned migration. So suppose you want to test your DR, there is no data loss. You could switch over, like we just talked about. The primary becomes unavailable. You could switch over to standby. The standby becomes the primary, goes to the primary role. You minimize the downtime. There's also a mode called failover, which is unplanned migration. So let's say this availability domain has a problem, has an outage, something goes wrong. You could always do a failover. In this case, there's a minimal data loss, and then there are ways to mitigate that. But this is one option you have for disaster recovery with Oracle Cloud Infrastructure databases. Now, Oracle has this best practices called Maximum Availability Architecture, MAA, and I would highly recommend that you actually read about that. And as part of that, one of the best practices guidance is to do both high availability and disaster recovery together, because you have options to do that, right? Now, we talked about in the previous examples, we looked at the primary and standby as a single instance Oracle database, right? We had just one single instance. But there's nothing which stops you from making the primary and secondary a rack database. Now, we talked about rack in the previous slides, right? It lets you cluster your Oracle databases, and if there is a problem with one of the nodes, the connection fail over to the other nodes. So this way, Oracle database is available from any of the nodes in the cluster, and basically what you get is high availability. So let's look at the previous example, which we saw in the previous slide. Now, in this case, you have again three ADs within a region. You have a virtual cloud network running here. You have within an AD, we talked about this in the OCI physical architecture module. You have three fault domains always. Whether it's a single AD region or a multi-AD region, and AD always has three fault domains. Now, what you can do is you could create a rack database in this AD. And one thing which I want to also bring up is when you create a rack. This is a managed rack offering. When you do that, automatically the software is intelligent, system is intelligent to put the primary in fault domain 1 and the second node in fault domain 2. Why? Because a fault domain 1 can become unavailable for some reason, right? And the whole idea of a rack is to provide you high availability. So if this is unavailable, the connections actually switch over to the second one. So we have to make the services fault tolerant ourselves. And this is something which we do transparently for you, right? You don't have to choose because our SLAs are around making things fault tolerant to the maximum extent possible. So this is how you do your, you create a rack here, right? Now for AD2, you could do the same thing. You could have another rack here. Um, um, uh, and then what you could do is you could establish data guard between them. So literally then this becomes your primary database and these becomes your secondary databases. So if there is an issue within, let's say, fault domain 1, you still have your database running. Same thing with your AD2. If there's an issue, you still have your database running. Let's say if the whole AD has an issue, is unavailable for some reason, you can always switch over to your AD2 and you still have your database up and running. So this way, by using HA high availability and disaster recovery together, or using rack plus data guard, you are guaranteeing the maximum availability for your database. And again, I'll highly recommend read a little bit more on maximum availability architecture. There are lots of other capabilities, lots of other features. It gets very complex. This is a foundations course, so hopefully this gives you a good idea. Now, what happens in case of a single AD region? Everything we talked about is great. If you have a multi-AD region, fine, I understand that. What happens in a single AD region? Now, the same thing. Now, you have a region. Now, we have one AD here. I think I'm not showing the AD sort of a boundary here, but let's say this is one AD. Within the AD, you have three fault domains, right? Now, what you do is like the previous example, you create a rack and system automatically puts the first node in fault domain 1 it puts the second domain in for domain 2, right? That's the system does that automatically. Now what you would do is you create your secondary databases, but since you don't have four fault domains, one of the domains will have both the primary and the secondary database, and this can be in a separate fault domain, right? And the system again takes care of that. And then of course, you can establish data guard between them. Now, this is what it says: primary and standby are two node rack, both are in the same AD. Only one of the two nodes of the standby database can be in a fault domain that does not include any other nodes from either the primary or standby database, meaning this is you will only one of the two would not share its space with either the primary or the secondary, right? So now if let's say if fault domain 1 becomes available, you still have your database running. If fault domain 3 becomes unavailable, you still have your database running. If fault domain 2 becomes unavailable, you still have your database running, right? So still sort of you get this high availability, but just it's a different kind of a design paradigm compared to a multi-AD region. So just keep that in mind. But it's a sort of a best practice. If you have one AD, you could still go ahead and use rack along with data card. And this is our optimal architecture. We recommend that you read more on this and use it. Well, so this brings us to the final part of the module, which is autonomous databases. We talked about autonomous databases, self-repairing, self-securing, and self-tuning. There are three, the two different modes called shared and dedicated. Let's talk about them in a little bit more detail. So first is, before we get into that, there are two kinds of workloads which are supported with autonomous. One is autonomous transaction processing, also called as ATP. The other one is called Autonomous Data Warehouse, sometimes referred to as ADW. This is for OLTP, transaction processing workloads. This is for OLAP, analytical processing workloads, right? Makes sense. There are two kinds of deployment options. You have dedicated, where you have exclusive use of the Exadata hardware. Now, all this autonomous is running on Exadata, right? So you get full access to the Exadata hardware. In this case of shared, you provision and manage the autonomous DB, while Oracle handles Exadata infrastructure deployment and management. And both these options support both ATP and ADW. So why use autonomous, right? And we talked about the three key characteristics of self-repairing, self-tuning, self-securing, self-driving. The idea here is there are lots of tasks which get automated with autonomous, right? Backing up the database. You don't have to initiate the backup. We do that automatically for you. Patching the database, including maintenance without any downtime. Remember, we talked about self-repairing, right? We do automatically protect from all types of downtime, including those that happen with patching and maintenance. We do that. Then upgrading the database, we again take care of that, so it's sort of seamless to you. And then finally, we talked about self-driving. We tune the database, automatically patch, upgrade, tune the database without human intervention or downtime. Well, so that brings us to the conclusion of this module. These are the different DB services we talked about at a very high level, at a glance, very high level. Management for the VMDB and the bare metal and the Exadata is customer's responsibility. In case of autonomous, it's Oracle's. Makes sense. Updates, you can see customer initiated. In case of shared, it's automatic. In case of autonomous dedicated, there's something called customer policy control. So you control how you apply your updates. Scaling, storage is the scaling supported by VMDB. Why? Because it uses block storage, so you could change that. In case of bare metal DB systems, it's CPU. Exadata, you could actually change the CPU within an extra configuration, and across extra racks, you could always change storage. You could go from a quarter rack to a half rack to a full rack. Autonomous, you could scale both CPU and storage. So this is again a key reason why you would use autonomous, because you could online scale both CPU and storage. And you could see some of the things around backups, customer initiated, still automatic, but customer initiated, in this case, it's automated. You don't even have to say, we do that for you, right? And you can see storage, rack, some of the data guard options. So this is a foundations course. Hopefully this gives you a quick overview of the different services we offer and the different use cases for those services. So that's it, folks. In this module, we looked at the various DB options. We dived a little deep into DB systems, what all different operations you could perform. We looked at the two important considerations with any database offering: managed database offering, backup, how you do backup and restore, and then how do you do high availability disaster recovery. And then finally, we concluded the module by talking about autonomous databases. Thank you so much for your time. I hope you found this information useful.